Just realized that I was not recording. Yeah. So for developers, if you are developing, if you want your contract to be used by other people, like if you want your token to be integrated on the various exchanges that we have, then you normally give out your contract address. We spoke about the different types of addresses that we have on Ethereum, and one of them is the contract address. So you normally give out the contract address and the JSON interface of the contract. That is the application binary interface. So application binary interface are similar to APIs, and so you have to give them the deployed address and the ABI. In the future, the ABI will be stored on SOAM. So anyone can look up the ABI just by looking at the Ethereum address. So with SOAM, this will be easy. I don't know if they were able to do that in such that if I just give you the contract address, you will be able to see the contract ABIs without me having now to share the contract ABIs. And then other developers, it will be easy for other developers. So we I had during our pain point, or the ideas that the ideas we shared at the end of lesson 1 and 2, I mentioned about IPFS, and so IPFS is a decentralized storage system. It is not related to Ethereum directly, but can be integrated with Ethereum. So is much further along in code maturity. So this one, they have actually developed, they have gone a step ahead than SWAM. It's much further along in code maturity, scaling, adoption, and also even community-wise, they have a bigger community, and with a dedicated developer community. So for anything in the blockchain space to be successful, you must have a community and you must have the developer community. So if a project or the coin that you are, maybe a coin or a blockchain system that you are supporting or you are part of, lacks the two, then uh, that 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 project fails. So if it's lack community and it has a dedicated developer community, it will also fail, because you need community to market that project you are doing. If it has a community and it doesn't have developer, then it will be overtaken by other projects, or other people in who has community and developer both will have will have to surpass your idea. So those are the two main things. So those are the two main things that I normally look when I'm investing in a project, or when I'm starting to dedicate myself in a certain project. Then SWAM's core storage component is an immutable content address and addressed chunk store, other than a generic DHT, distributed hash table. So you can approach to SWAM, use it as a crowd hosting in IPFS. Yes. Uh, uh, yeah, it's internet interplanetary file system. It's not internet protocol file system, but interplanetary file system. Yeah. So think of it as also, you can think of it as as Google Drive, but a Google Drive for everybody, which is offered for free, and you are able to like track, see who has shared your file, and yeah, everything. So you can upload and you can upload to SOAM, use it as crowd hosting in IPFS. You can in IPFS you can only register stroke publish content already on your hard disk. So you can do that. You can register stroke publish content already on your hard disk. But on Swarm you can use it as hosting, the normal hosting like the cPanel we do and the crowd hosting that we normally have. So you can do it the same way. So there is also a similar service that spoke about yesterday. That was Ivan on Tech, which is part of the developers group. That is Moralises, not Morasis, Moralises. Moralises is a serverless host for smart contracts. Yeah. The two systems use different network communication layer and peer management protocol. So these are they are using different network layers and communication peers or peer management protocol. And this is where now that with all these protocols and all these technologies coming into blockchain and trying to help us adoption of blockchain, there comes a problem with how do they connect, and that's where now you come with oracles and bridges to, and then as a developer you have to develop these technologies having the capability to interpolate with others, like to interconnect with others. Yeah. So Swarm has deep integration with Ethereum blockchain, and the incentives system benefits from both smart contracts and the semi-stable peer pool. So this is how the system now looks if it has all the FISOM and IPFS. And of course, we have Whisper, which is a communication protocol for dApps to interact with one another. So in here with this arrow, we will have that Whisper. We will have Whisper in these arrows so that we can be able to communicate with it. So your contract, as I mentioned, lives here on the Ethereum virtual machine. And then we have Parity, and then we have Geth, and then here we have MetaMask. So MetaMask will be used to will be used to sign a transaction or trigger a transaction here. And then using using web3 JS and using web3 and a web app. Wait a Using web3.js hosted on IPFS, you can be able now to upload your content on IPFS the same way. If your contract ABIs are hosted on SOAM, so you can be able now to connect them using Web3 to IPFS. And from the other end, you can see the Ethereum name service. Yeah. So you can see these two different networks, but here in between we have now the Whisper network, and also we have Web3. That Web3 interprets everything that you have been able to write here as a smart contract to be now translated to an application that users can be able to use. That is the web app or the dApp on your mobile phone. Then here we have MetaMask. If it's a web app, then you will have to use MetaMask to sign this transaction or to initiate a transaction. So yeah. So yeah, we saw that was the part one of Ethereum ecosystem. And then down below here, we have the Ethereum and Bitcoin comparison. So we have Ethereum
Hello.
is not just, yes?
So from that chart, so our MetaMask becomes our DApp.
Kind of, it becomes kind of our DApp. Yeah. It becomes kind of our DApp. But in, yeah, because it's also connected to Web3. But for now, yeah, for now, the smart contract you are creating is the one that is has been so MetaMask is the one used to kind of trigger the transaction on a DApp. So the smart contract that you have created is the DApp. Let me show you. I don't know if I will be able to. Haven't started the project in a while, but let me show you the project. Capstone. Okay. So this one, let me share my screen. So this one is an application that I was building, the one that I was talking about. I haven't learned it in a while. So I think some of the, or let me just share the one I normally use for, because this one will take a long time. This one will take a longer time. I'll show you tomorrow. So, but yeah, because I haven't started the gate, and then if I start, the machine will start slowing down. So I'll make sure tomorrow I'll do that. Let me share the Uniswap one. Yeah. The same, maybe. So Uniswap is a decentralized application or a decentralized web app. A decentralized web app. So if we launch it, I don't know if I have a board here. Okay. So this is our DApp. This is our DApp. But to complete these transactions, or to trigger a function, or to trigger any transaction, you need MetaMask, so that you can be able to trigger. So MetaMask is like a trigger. It's like the trigger to make the DApp work, or to make different calls on the smart contracts. So let me check for a board here. Draw a simple diagram. So for you to access the DApp, the application, you need MetaMask. Yeah. think of MetaMask. If you are shopping online, if you are online and you are shopping and you have seen something cool on the e-commerce system and you need to buy it, so for you to complete or to make that purchase, you need on review. Okay. So, okay. Oh, already created. So I'll take the first here and call it MetaMask. Then we'll draw another arrow here. Then have it as different color, and then we'll have another one that has a different color. And then we'll have this, and then here we will have, so this is our DApp or smart contract that has been created into use with a cool UI. So with a cool UI. So smart contract generally themselves don't have a UI. They don't have a UI. So this DApp has a cool UI. So you can think of this one as the Uniswap or any application that users can interact with. So here we have the web3.js. There we have the web3.js, which is used so as a connection between this one and this one. And then here we have the EVM. We have the Ethereum, have the EVM, but still you have to remember that MetaMask is still connected separately. MetaMask is connected to EVM because it's getting something. It's getting the accounts from the EVM. See, and in between here there is nothing which is they are controlling or they are using. And then here we have now this which is now either the IPFS or SOAM. So we have so here under the EVM we have now we have SOAM. And if your application is now it's a DApp that uploads photos or content on the blockchain, you have IPFS there. So your system now is communicating, and then you have to remember that this one is still connected to EVM, and this other one is getting something from EVM, but here you have written a protocol on how you can upload things on IPFS. Yeah. on IPFS, how you can upload your smart contract has a function to upload a photo. So when we start smart contracts, I'll show uh, different examples or tutorials on how you can initiate you can create a function to upload to files to IPFS. Yeah. There is somebody who is creating an application on COVID certificate, whereby if somebody is vaccinated, then a blockchain or a certificate of that blockchain, a certificate of COVID is created on the blockchain. So I'll use that one as an example. Yeah, I hope this is clear now.
Yes, it's clear.
Yeah. So MetaMask is the wallet, but in some other cases, if still since MetaMask is also connected to uh, Web3, it also uses Web3 so that it transforms this account into something user friendly. Then it's also adapt on its own. Adapt on its own. Yeah. So that is the that was the first part of the Ethereum ecosystem. So on our next part, in our other class, we saw in our other class we saw the comparison between Ethereum and Bitcoin and the differences. So, and I mentioned that Ethereum is not just a digital currency; it has a lot of utility, and that's why it has a lot of utility. So you can compare it Bitcoin the year it was created. Based on the year Ethereum was created, you can see that Ethereum was created in 2009, while Ethereum was created in 2015 by Vitalik. Then Bitcoin, I said Bitcoin is more of a world payment system, while Ethereum has a decentralized programmable platform which supports a decentralized or distributed apps, learning, smart contract, and using digital tokens. Then we have Bitcoin enables peer-to-peer transaction, purchase of good, long-term storage of value, and Ethereum enables peer-to-peer transaction and can handle accounts, transactions, as well as store, execute newly created code and program logic. Then we have based a comparison based on the fractionally design. So Bitcoin in itself is deflationary by design due to its limited supply. So the supply of Bitcoin is 21 million, whereas of that of Ethereum is 18 million, but they have a capability of creating others if the Ethereum supply gets finished. So the total existing coin as per now is 104 million ETH. The market capitalization is 13 billion USD. The smallest unit is WEI. So the smallest unit here is Satoshi. Yes.
Okay. On concerning,
Mhm.
hello,
Yes, I can hear you.
concerning now, as the total existing coins, you can
Mhm.
see Ethereum is, let's say, almost times five
Yeah,
what we
yeah.
have in BTC.
Mhm.
So that feature of now limiting the amount of coins that can be available in circulation, is it part of the architecture or it's
Yeah,
something
yeah.
that can be incorporated in later?
It's the design. You initially, when you are creating a coin, you set up the amount of money you set up the amount of you project how much money you want, or how much coin you want your project to have. So for Ethereum, these coins are actually created by need. They are created by need. So once more people or more contract are being built on Ethereum and more transaction are being, as you can remember, we said that one way of creating coins in Ethereum is through mining, and then there is other, like for example, the coin that I created, we had a total supply of initially we had a total supply of 10 billion, but as the project grew bigger and we saw that we needed a lot of money, we minted another 10 billion. So we have like a supply of 20 billion coins. So it's something based on the way you design your smart contract, or based on the way you design your blockchain, it's something that you can be able to see. So since this one Bitcoin, I believe the person who was creating it as an experiment, and that's why he limited the Bitcoins to 20 million. There are other contracts that once the supply of the coins is finished, the contract, the coin becomes useless, because everybody now has the supply of the coin is finished. Yeah, all is like over. Yeah. So this
Okay.
for yeah yes
So that is a feature that can be revised with time.
yeah
It's
yeah.
not like immutable.
It's immutable for blockchain. It's immutable for blockchain, especially for Bitcoin. For Bitcoin, it's something which is once you light, if you don't have an upgrade, a way to upgrade your systems, then it becomes hard to actually change it. Yeah. But for Ethereum, since the Ethereum has a way that they can be able to upgrade, and some of the Ethereum network can work independently without interfering the smart contracts, then they are able to like upgrade and do a lot of upgrades. So they have been doing some upgrades to various protocols on their network. Yeah. So when you're designing, you have to be, it's just the same as designing a house. So there is a way that you may design your house that later on you see that if you want to add a new feature, you will have to like reconstruct the whole building, or maybe reconstruct a room. So if you are creating a design, you have to create a dynamic design of your house or your blockchain, so that when it comes to upgrade, you don't have to like reconstruct the whole building. So the same case for building. If right now they were to kind of start upgrading Bitcoin, it will bring a lot of disagreement on the network, and developers. Also, in terms of developers, Bitcoin does not have a lot of community support. It doesn't have a lot of developer community support, unlike Ethereum. It only has the community, that is the traders, the people who still want to use it as a payment. See, yeah, and yeah. I hope, okay, yeah, I hope that one is uh, clear. Yeah,
Yeah, it is clear.
yeah. So then we have the pricing value in Bitcoin. These are not the current prices. These are not the current prices. So, because right now Bitcoin is at 20, is it not 20? But it was dropping. It's dropping. So these are not the current price, but they differ in price. Yeah. So we also have these are graphs explaining the Bitcoin versus ETH issuance model. So at a particular time in time, theoretically, BTC will be limited, but 18 million ETH per year are kind of generated, and then yeah. Then we have the top currencies. This one I think everybody knows about it. That is CoinMarketCap. This is where you can get the current prices of every coin in the market. And then we have Ethereum. This one I spoke about on the previous class. That was Ethereum is changing to proof of stake, and we saw the differences in terms of the consensus mechanism, and yeah. So under nodes, under I didn't want to talk. I didn't want to like talk about proof of work and proof of stake at this particular lesson, because we will go deep into it, but maybe we can have a look at it, because it's keep on popping on the slides. So proof of work versus proof of stake is that the probability of mining a block is determined by how much computational work is done by a miner. So this one is actually where you prove, you solve a mathematical puzzle, yeah, you solve a mathematical puzzle, and then you show you are working on how you have done it. And then on the other hand, the probability of validating a new block is determined by how large of a stake a person holds or how many coins they possesses. So that makes you that makes you a miner that way, which is easier because you don't have to use a lot of tools or energy to do that, to validate a transaction. Then a reward is given to the first miner to solve the cryptographic puzzle of each block. So the first miner is given a reward. So the validators do not receive a block reward. Instead, they collect network fees as their reward. And then we have the other difference is that network miners compete with one another using computational power. Mining communities tend to become more centralized over time. So we have different mining companies, and the reason then we have proof of stake system can be much more cost and energy efficient than proof of work system. Sorry, but are less proven. So with the recent adoption of Bitcoin in El Salvador. One of the major reasons why El Salvador, or I think why El Salvador made a big move to adopting cryptocurrency was, one, there was crackdown in China because of miners who are doing mining and maybe illegal mining, creating leaks and everything, and then they felt like they were being harassed. That was one of the reasons why maybe El Salvador did that, apart from other things that might have influenced. Yeah. Yes.
Ethereum uses proof of stake or proof of work.
Currently, they are migrating to proof of stake. They are migrating to proof of stake. Another reason why Ethereum gas prices are high is because of using proof of work. But with proof of stake, there is less gas, and also there is less energy used. So node validators must pay a security deposit in order to be part of the consensus. That one thing they normally do. The possible future switch from POW to POS may provide the following benefit. So one of the major benefit is that energy saving. We will have a safer network as attacks become more expensive. Because for you to create an attack on a proof of stake, you must have a big amount of coins that you possess. If a hacker would like to buy 51% of the total number of coins, the market would have reacted by fast price appreciation. So if a hacker wants to do that 51% attack and you are on a proof of stake, then the price of the coin will be high, making it impossible for the hacker to even purchase the coins. Unlike proof of work where you need energy, just you need to solve that cryptographic puzzle, and using computers, and which computers the price of computers does not actually change it. It kind of depreciates with time. So buying machines and things, you can be able to do that. Yeah. So if you can remember from our previous lessons, we talked about quantum computing and 51% attack as one of the challenges blockchain is having, and proof of stake solves the 51% attack. So if one validator creates an invalid block, his security deposit will be deleted. That's another advantage. So there is no room for creating invalid blocks, because one, you will lose your stake, and also you will lose a deposit of your coin. Actually, these coins that you are holding are the ones you kind of deposit, you deposit so that you become a validator. I showed you an example of a software that does that. This is the Zero Terminal, which was created to help people to be able to hold and interact and vote for governance on the Zero ecosystem. So we have a comparison between Bitcoin and Ethereum in terms of block size. So Ethereum block size has been continually adjusted to facilitate a healthy network through a voting process. So the number of transactions in blockchain per day is 332 million, whereas the number of transactions in blockchain per day is 455 million. Then blocks in Bitcoin blockchain is 564K. Blocks in Ethereum blockchain is 7.23 million. As you can see, the block sizes are bigger, and once they move to proof of stake, it will be actually more. It will be more. Then the average block size is 767 kilobytes. Average block size is 21 kilobytes. This also makes the smaller the block size, the faster the transactions will are. So block size limit is 1 MB or 8 MB. Block size limit limited by gas limit. So the block size is limited by gas limit, which is the total overhead for all operation within the blockchain. So this is where now This is where I was talking about limiting. When you are creating a smart contract, you need to limit a lot of functions. So if you are uploading to Ipfs, you will use a larger, you will use a big, you will use a lot of gas fee, but the size of your block is not limited, unlike of that of blockchain. It's limited by your pocket. Yeah. So picture gas fee as or gas fee as the normal gas you put on your car. So if you want to go to Mombasa and you buy gas worth 1,000, then definitely you won't be able to reach your destination. So that's how you are not limited to go further, but if you have a lot of gas fee, then you can go far. Then we have this, how you can be able to see the difference, the number of transaction per day in Ethereum and Bitcoin. So the red one is for Ethereum, and as you can see, they do a lot of transaction in a day. And then we have block size in Ethereum and Bitcoin. So as you can see, this one is about 1 million. Yeah. And then this one is lower. Yeah. So we have another comparison in terms of cryptographic algorithms used. So Ethereum uses ETH hash as cryptographic algorithm, over which special hardware will not provide any advantage. So average block time for Bitcoin is 10 minutes. Cryptographic algorithm used is secure hash algorithm 256, for which special hardware can be used. So this one requires special hardware. That's why mining Bitcoin is expensive. Uh, Average block time for Ethereum is 10 to 20 seconds. So as you can see, the block time mining is less because of the above differences. These ones, because of the number of transaction, with less block size, then the transaction goes faster because you are transacting data. So using the Ghost protocol, cryptographic algorithm used is ET hash. The most commonly used hashing function is Keka 256, also called as secure hash algorithm. So I mentioned that there are various type of cryptographic algorithm, and we have come across another one, that is secure hash 3, which is more complicated and memory intensive, for which no special purpose chip provides any advantage. So Lance and Ethereum virtual machine, and the programming language is Solidity. So that is the difference or comparison between Bitcoin and cryptographic method used. Then we have, on the Ethereum ecosystem, we have tokens. So on a later lesson, we'll come and learn more about tokens. So there is a big difference between coins and tokens. So tokens actually they are two completely different concepts. So coins are often called altcoins, are digital money created using encryption techniques that store value over time. They are tied to the public open blockchain. So these are like the ETH itself. ETH itself. So ETH has a coin, Omni has a coin, the Lipo has a coin, Dogecoin has a coin, Peercoin. They are tied to public open blockchain. So they are like native coins on that particular blockchain. So they are not native to blockchains like Ethereum, which has ETH. They may be sent, received, or mined. Coins are not meant to perform any function beyond acting as money. Well, on the other hand, tokens can be used for payment, but the main difference is that it gives the holder a right to participate in the network. So token may perform the function of digital assets like company shares. So people, instead of selling shares, they can sell tokens as a guarantee that the project will succeed. Tokens have certain use cases, but only inside certain projects. Like BitTorrent coin or Filecoin, like Filecoin, Banco, Enigma. Enigma, they had a very exciting project. Enigma was creating a project that you could use the Enigma token to purchase in little, think of it as M-Pesa bonga point or bonga points that Safaricom offers. Yeah, think of tokens as bonga points. So if you want to redeem your bonga point, you must use them under selected stores, like Safaricom store. If you want to buy a phone and you top up you redeem up, you top up your bonga points. And then nowadays I've seen they have selected some few shops whereby you can be able to like purchase uh, purchase an item using bonga point on a in supermarket. You can also redeem those bonga point to buy your airtime. So think of tokens like bonga points. Yeah, they can only be used in a certain, so you cannot use bonga point to buy airtime using to buy airtime for your Airtel line. Yeah, so they are basically used in a certain project. So creating a token is easier than creating a coin, because you don't need a lot of you don't need to like create for coins. You have to create an entire blockchain, but for tokens you just need to create a smart contract. And the code is available to create because it's already public on different on GitHub, on Etherscan. You can copy and modify the already existing coin code. So you, and also you can just use the Ethereum ERC20 token standard template from the Ethereum platform. So tokens are blockchain based abstractions that can be owned and that represent assets. So another thing is that tokens are like within a specific blockchain. So like Enigma coin or Filecoin uh, are basically created under the Ethereum blockchain. So for them to like interact with other blockchain, you have to now that's where now the lapped ether comes in. So for you to like interact with other coins that are in other blockchain. So let's say, for example, you own Enigma and you want to exchange it for Zero. You must lap it first, so you get lapped ethers, and then once you get lapped ethers, you are able now to migrate to another blockchain. You are able to migrate to another blockchain. So as for this picture or this image, we have for coin infrastructures. So Filecoin is mainly, I think Filecoin is used together with Textile textile and textile and what textile and IPFS. Yeah, it's used for that. And then we have at the lighting of this document, Polkadot was still did not have their own blockchain. And then we had EOS. We have EOS for coin infrastructure. So all these coins have a specific use in different infrastructure. And then we have others for financial services like Enigma, like Celsius, like Comsa, and net on. Yeah, so and then we have vertical apps. So we have like Dragon Coin, we have Open Zeppin, and we have different coins here that have different. This one is for accessing health, yeah, medical chain, yeah. So we have different coin based on maybe if it's for core infrastructure, for financial services, and vertical apps. Yeah, so tokens are created on Ethereum, they normally land inside the 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 blockchain. Back to the example of Bonga Point, as of that of Safaricom. So you cannot transfer Bonga Point to another network like Airtel network or Telecom. And also for Airtel or Telecom, I think they have the other points. So you cannot transfer those points back to you cannot transfer those points to Bonga points. So you need to like change them to Airtel airtime, and then from Airtel airtime then back to maybe Real Cash, and then from Real Cash you buy the Safaricom airtime, and then from the Safaricom airtime you are able to get the Bonga points, of which is a long process, I think. But nowadays you can be able to like buy airtime for Airtel using M-Pesa, and yeah. So there was a bridge there using the so think of wrapped ethers as now the M-Pesa pay bill. Yeah. So tokens are yeah. So I've talked about token being based as blockchain-based abstractions that can be owned and that represent asset, currency, or access right. So for for access right, if you want to access files in IPFS, you will have to you must have a file coin so that you are able to access those files. Or if you want to access a specific service like uh, like I'm trying to think of an example. Like healthcare. Let's say you want to access health or to access an entertainment. A good example is like that one of a casino. So casinos do have tokens, all tokens. They call them. Don't know whether they call them tokens. So for you to access services in casino, you must have those tokens that they normally give you. So you must exchange them, and different tokens have different value in a casino owned restaurant or a hotel that has a casino. So to access maybe the hotel, you must have a specific coin token in that casino. Yeah. So token is commonly used to refer to privately issued special purpose coin like items of insignificant intrinsic value, like transportation token, rounderly token, and arcade game tokens. So often restricted to specific businesses, organization, or location. Physical tokens are not easily exchangeable and typically have only one function. So nowadays, token administered on blockchain are defining the word to mean blockchain-based abstraction that can be old and that can represent asset, currency, or access light. So for from uh, the first definition or the first example, with token we are able to see different applications of tokens, and we have seen different companies create a multi-purpose tokens that serve different that offers different services. So many blockchain tokens serve multi-purpose globally and tradable for each other or for other currencies on global liquid markets. So how are token used? Tokens, the most obvious use of tokens is as digital private currency, but tokens can be programmed to serve many different functions, often overlapping. A token can simultaneously convey a voting right, an access right, and ownership of a resource. So possible applications include currency. A token can serve as a form of currency with a value determined through private trade. Resource, a token can represent a resource and or produced in a sharing economy or resource sharing environment. For example, a storage or CPU token representing resource that can be shared over a network. So a good application of that is BitTorrent. BitTorrent. BitTorrent, if you want to share your, I do have that application. I normally download. I hope you can see my screen. So this is BitTorrent. This BitTorrent is an application that you can be able to use to download your movies and everything. So if you want to get access to different if you want to like to upgrade and have a secure maybe something to share your CPU, there's an option here for you to bit options. So no. So on under BitTorrent, this software, if you want to share like if you want to share your CPU for usage, you may or if you want to access a specific, if you want to share your CPU, you will be rewarded with BitTorrent tokens. You will be rewarded with BitTorrent token, and this is a good example of sharing your CPU and earning. And then we have this other one that I think I showed you the other time about governance and voting. So if I want to like pass a vote and become a participant on this place, I will stake the coins that I have. So giving me lights to vote on different protocols and how we want the system to be based. So this means that I will also lose my coins if I create an invalid block or if I vote differently or not I vote differently, but if I create an invalid block, I will lose my coins, and I lose the staking power, the voting power. I lose the voting power. So that's how consensus, different consensus mechanism work. Yeah. So this one, yeah, as you can see, there is a time left. This one is a voting. There is some voting going on here. So most people have said yes. Like 57 have abstained, 88 have abstained, and right now I don't have voting power because I have not staked my coins to get that power for voting. Yeah, but if I get it, if I stake my coins and I create, I'll be able now to say yes or no. And then, so like for this one, last year, Zero was being called Zero Gold. So people voted that it should be called Zero instead of Zero Gold. The community voted through this platform, and it was the name of Zero was changed from Zero Gold to Zero. So that's how consensus work. That's how you can, that's a small change, but it shows that the community is interested. Yeah. So let me share the how to use the token. So that is one of the use of sharing a CPU and storage in BitTorrent token and other coins. So still on under how coins are used, we can use tokens as a token can represent ownership of an intrinsic or intrinsic tangible or intangible asset. So it can represent gold, a real estate. There are people who are currently that are joining, are creating tokens that show you that you own this particular real estate, or or a house. It can represent a car, an asset like a car, oil, energy, MMOG items, and others. Then we have access. A token can represent access right and grant access to a digital or physical property. There was there is this something called there was an NFT that was trading, that is people are buying Genesis. Is it Genesis? It's an artificial land. Artificial land. So to access that artificial land, you needed coins, crypto. I don't remember the name. Land game. Yeah, it was a game. So people were buying. Decentraland. Yeah, this one. So you could buy and sell land virtually. Well, so in discussion forums, you can contribute into discussion. So for you to participate in discussion, you need a token to do that, or you can earn token if you have participated in the discussion forum. An exclusive website, an exclusive